Rebecca Clem, the Numbers Lady, and this is number 3 in the series of ideas about compulsory math education and mathematical thinking, which I would hope the new administration starts to take into account as we continue here in 2021 with the Biden administration. So, I talked the last two about my larger numbers, which are here to be able to use in storytelling and puppets. And I also created small ones because teachers and parents said to me after I did a musical that they needed some tools for the children to learn about place value. And so I spent a lot of time in schools, having taught only middle school through PhD students prior. And I found out that we separate geometry too much from counting. So I tried to put them together, and I have many learning tools that I've created because I'm also an inventor to create things that are not available, which I think contribute a lot to mathematical thinking. So in addition, I have these small ones. This is for the place value. And look, notice they stick together, or you can wear them as a hat, or you can wear them as a necklace. You can take them apart because they are matched with, or they stick together with magnets inside. Now that requires a lot of extra safety testing and ways to make them so that they're three-dimensional, so that they can be in little bags on the side. All of these things I make are wonderful for washing and wonderful for just air drying, but they are little characters to hold in your hands. I also use these for teaching advanced placement students about permutations and combinations, and I use them with first graders to see about different kinds of arrangements. So they're getting them ready, they're thinking about things, not just rote memory, because math did not fall from the sky onto worksheets. We need to talk about where it came from. So you notice they form a color wheel. The numbers I put them together this way. No matter what size they are, they have the same face and they have the same colors. When I make them with slightly different fabric, of course, they're not quite the same colors, but it's the same idea that it creates a color wheel because they are a team, they fit together, and 0 is the gold in the center. So what I like about the magnets, and a lot of people say, why didn't you use Velcro? And so when I was developing these, I asked children, what do you like? And I had a survey of many, many students at science and engineering fairs and at math nights and in schools. Not one student wanted Velcro. Why? Because they don't like that it gets caught in their hair. It doesn't matter that some organizations have made millions of dollars with Velcro in their products. The children don't like them because they get stuck in their hair, and the Velcro then doesn't last very long. Magnets are magical and you can learn a lot. But what's interesting here is you can now make different numbers with them. So when they have magnets and they'll last, they're in little bags that are for safety. They have to be three-dimensional for the little bags to be in the seams. You have 32 and you have 23. So now the question is, what's the difference in value between 23 and 32? And all I can say is it's a lot more fun to do it in your hands, soft, friendly, not harsh, not fearful, than it is to put them on the wall. It has a different engagement of the learner. You are experiencing 32, you are experiencing 23. Now you can put those numbers on a whiteboard if you like and say, if these are pennies, or if these are numbers of dogs, with units, that to me is very important about teaching mathematics, with units, what are you counting? 1 plus 1 is not always 2. We'll come back on that. So 23 and 32, if in fact they're the same units, if it's pennies, how many more pennies do you have from 32 versus 23? It's constructed with the same 2 individual digits into different words that have different meaning. It puts these characters as the alphabet of the number system from which we create number words like 23 and 32. And then we can bring a third one in. And notice those are the only two-digit numbers you can make with 3 and 2. Let's bring a third one in, number 4. We have now 432 because the 4 is on the left. The 3 is in the middle, in the tens, and the 2 is in the ones. But we can move it this way. And now we have 324. How different is that, and how many different arrangements can you make by moving them around? And if these were pennies, we could order them from the largest value to the smallest, and you could subtract or learn from the top to the bottom or between each of them as they're ordered how much more money you would have, or number of dogs, or number of cats, or pennies, or jelly beans, whatever, depending on how you rearrange the numbers in your hands. Soft, friendly numbers you can count on. This is the Numbers Lady. I'll be back for session 4 next. Thank you.